Hi, everyone, and welcome to this special decarb webinar hosted by Sibo. The topic of our session today is how to prevent quality, throughput, and energy losses in cement manufacturing while lowering your carbon footprint. The challenge of decarbonization is faced by cement manufacturers throughout the world. In today's panel, we have brought three experts in the cement manufacturing industry to share their thoughts and strategies on how to optimize production processes to reduce emissions while maintaining or even improving overall process efficiency. Joining me today are Edelio Bermejo, Head of Research and Development at Holcim, one of the world's largest cement manufacturers. Edelio, can you tell us a bit about your organization and your responsibilities?
Yes, for sure. So, hi everyone. Holcim is a company selling cement, aggregates, concrete, and from 2021 selling roofing solutions with our very recent acquisition of Firestone. It's a 23 million Swiss francs net sales company operating in 75 countries and employing 70,000 people in all continents. So I'm Edelio Bermejo. I'm in charge of R&D and intellectual property at Holcim, and I'm leading our innovation towards greener and smarter products and solutions. Our innovation center is based in Lyon, in France, and it's supported by 5 regional centers, helping the operations in their innovation roadmap.
Thank you, Edelio. That's very interesting. We'll dig in deeper a bit later on in this session. Also with me today is Ian Riley, the CEO of the World Cement Association. Ian, can you tell us a bit about your organization and your responsibilities?
Thanks, Noah, and hello, everyone. So the World Cement Association was set up about 5 years ago to represent not only cement producers, but other stakeholders in the cement industry. And we really have 3 objectives. The first is to give a voice to cement producers, not only big ones like Holcim, but the small ones too. The second thing is to try to provide some practical help to our members to improve their operations, their profitability, and their sustainability. And thirdly, to accelerate the pace at which the cement industry is decarbonizing. So I've been involved in WCA for about 2 years now. I think this year is very interesting because we start to really see some change in pace in this whole decarbonization area.
Super exciting, Ian. Thank you for that. And our final panelist is Liran Akavia. He's the co-founder and COO of Sibo, the predictive quality and yield solution for process manufacturing. Liran, can you tell us a bit about Sibo and the work you do around cement manufacturing?
Certainly. Thank you, Noah, and Edelio and Ian. It's very good to see you in this panel. So Sibo is a predictive quality and yield solution. We use artificial intelligence to optimize the production process. We actually invented new technology. We call it process-based artificial intelligence. Those are algorithms that are designed specifically for the continuous manufacturing world, and those algorithms actually learn and understand specific manufacturing processes. The Sibo solution is using data from the production line against the result, the quality, the throughput, the emission, the energy, and the algorithms are helping manufacturers to optimize their production. The Sibo solution is answering the 3 most important questions when looking at process inefficiencies. Why the inefficiencies are happening, using automated root cause analysis. How to prevent the inefficiencies from happening, using predictive recommendations. And eventually, when is the right time to act, using proactive alerts.
Thank you for that quick overview, Liran. Now, going on to my first question for the panel, and that's for you, Ian. When we talk about reducing carbon emissions, that often means switching from fossil fuels to alternative fuels. And this has been done very successfully by many cement manufacturers, particularly in Europe. But before we dive into how they did it, there are some significant challenges our audience should be aware of, aren't there?
To put this into context, the use of alternative fuels is one of 3 of the traditional levers that we use to reduce the carbon intensity of cement production, along with energy efficiency and a reduction in clinker factor, which means using more non-clinker materials. The challenge with using alternative fuels is that many of them are waste derived, so they're not produced as fuels, and the quality of the fuel varies quite a lot. So you can have inconsistent fuel heat values, inconsistent moisture. You can have materials in the fuel that you wouldn't want to put in the kiln. So you have to be careful about making sure you have some control over the incoming system. You also get problems with the buildup of chlorine in the system. So there are specific process modifications that you have to make in order to use the alternative fuels effectively. And then another limitation that we see around the world, particularly in developing countries, is the cost of waste, or the cost of disposing of waste. So if you can throw away waste on the side of the road, that's always going to be the cheapest way of doing it. And so to burn waste, you need to have a well-regulated waste regime. So that then gives you the economic incentive to burn it or to do something else with it. So those are some of the challenges.
Yeah, those are some pretty big challenges to navigate through. So Edelio, LafargeHolcim is a global cement leader. In your factories, you've tackled these challenges head on and are now operating at a very high level of efficiency, while at the same time you are transitioning to a very high percentage of alternative fuels. So how did you do it? And what recommendations would you give to the cement manufacturers who are only beginning to take this shift, for example, in the US?
Yeah, so let's explain a bit about the LafargeHolcim strategy and our journey. Our innovation is based on 3 pillars: sustainability, cement and concrete differentiation, and digital. Annually, we produce 190 million tons of cement, and we're using 46 million tons of recycled product. And our decarbonization journey needs to go beyond. More than half of our R&D is dedicated to sustainability, and 44% of our patents are related to low carbon products and technology. So as part of this ambition, we have launched what we call the program of Plant of Tomorrow. Plant of Tomorrow is aiming at improving productivity and efficiency in our plants. It's about investigating how we can leverage on digital and how new technologies in every single step of cement production is helping towards this digital plan. And we have to do it in a holistic way. And that's where artificial intelligence, and I would say machine learning, are key for this journey. Artificial intelligence, and in particular the machine learning, can enable cement manufacturers to optimize their KPIs on carbon footprint, KPIs of use of alternative fuels. And we know that today we're generating every single day millions of data from the quarry to the customer job site. And we don't value this data mining fully yet. And that's the role of the machine learning, to translate these signals into tangible results, allowing us a quick reaction, as quick as we can. Few examples. Today, we are measuring the free lime every hour, which is the free lime of the clinker after the burning. That means that we're doing that every hour. That means that in between, 150 tons have been produced, and the next check will be an hour later. So we need to react fast, faster than every hour. Another example, we're measuring the compressive strength of cement every day, and we need to wait 28 days in order to confirm that the cement will be complying with the standard class. 28 days. So we know today that with all the data we're generating in our plants, be it on the free lime for the clinker, be it on the initial compressive strength, we can predict the performance features of our cement without waiting 28 days. And for this, you need to trust in artificial intelligence and machine learning. Even, and that's something which is quite singular, even if you don't understand everything. We're experiencing right now a real revolution. And I remember the time when I was personally using multilinear regression tools, and it was very complex to me to explain to others in very simple terms. But today, put yourself in the shoes of the kiln operator. His experience at the decision-making process has been built over years based on acceptable number of real-time values, acceptable for our brain to manage. Today, it's totally different with machine learning. The decision is still made by the operator, but based on the number of values by far higher and interlinked trends confirming the accuracy of the figures. So obviously we need to seek for experts in machine learning, even if they are expensive. Why I'm saying that? Because quite often we're listening that, oh, these guys is very, very expensive. But this is a field that requires significant expertise to do it correctly. And the payback is guaranteed, I promise. So you need as well to go through a holistic approach. As I said, everything is interlinked. Enrich your models with a chemical, physical models. That's what we do at Holcim for the prediction of strength performance that I was mentioning before. No need to wait for the 20 days test to guarantee the performance of cement. No need to wait for the grinding of the clinker to predict what should be the addition content. Consequently, we optimize the addition content based on the clinker quality for a given performance required, which means that we can optimize the clinker content, then we lower the carbon intensity at the very, very maximum. And all this thanks to the machine learning.
Great, that's a lot of great food for thought. Thank you, Edelio. And that leads me to my next question, and that's for you, Liran. Sibo has some really unique experience and expertise in using artificial intelligence to enable the cement manufacturers to both increase alternative fuel consumption and also maintain or even improve their key KPIs like quality, throughput, and energy efficiency. So could you tell us a bit about how your technology can do that? Do you have any examples that you can share with us?
Yes, certainly, Noah. And I would like actually to connect the dots that Ian and Edelio spoke about. So Ian mentioned the complexity of the process and the complexity of the fact that when moving into using more alternative fuels, there is an effect on the process. And from one hand, you would like to increase the use of alternative fuels. On the other hand, you would like to maintain your capacity or even increase it. You would like to optimize the quality, and you would like to keep all the other parameters as optimized as possible. While Edelio is speaking about the fact that in the past we used to do it with our brains, handling a set of data points, and today we actually can do that while looking on a much bigger set of data points to optimize the process. So let me quickly share with you a few slides that tells the story of those two points that were mentioned. Sibo is a decision support tool. We actually stand next to the operators and the process experts on their decision-making process. Each operator and each process expert is taking dozens of process-related decisions every day. And Sibo helps them to make those decisions much more accurate. Let's take a quick look. At the end of the day, we are all interested in efficient production process. For that, some companies install advanced process control or an expert system. And everyone is having human looking in the entire process. Advanced process control or expert system is usually siloed. It's usually on the kiln or on one of the mills. While we need global optimization, there is a relationship between the raw material, the process itself, the cement mill, and the 28-day strengths that Emilio mentioned. And we need to look at the process end to end. Now, when we install an advanced process control solution, we look on a siloed area, and we need a human to look at the process end to end. For the installation of an expert system, we have a research, and this research is based on human process-related decision-making. While we maintain the expert system on the day-to-day activity, there is also human-based process-related decision-making. So what we can see here is that our process depends heavily on humans and on their process-related decision-making. And as we know, from the human point of view, not all humans will get the same decisions. Some has more knowledge, some have less knowledge. Let's see how this journey of taking a decision based on data from the human point of view looks like. So the way most of the plants in the world work, in the past at least, and in many companies, it's still the present, there is data coming from the process, from raw material, from quality, and other data sources like the alternative fuels and the weather around the plant. Hundreds of thousands of data points. And since we can simply not analyze them all, we look on a few tags only, based on our assumptions and knowledge. Then we run a few mathematical equations against them, then we prioritize and conclude. This is the traditional method that works for many years, but this method has a challenge, and the challenge is the blind spot at the early stage of the method. We have an assumption, and based on our assumption, we select the tags. But what happens if we miss something? What happens if we don't see all those relationships? So let's sum it up quickly. This type of analysis, where the data is analyzed on few tags only, and the process expertise are based on humans. It's assumption validation only. It happens ad hoc. It's not continuous usually, and it's silent on a specific part of the process. While when we look at the decision-making tree and the fact that the plant is dependent on the decision of humans, we would like to have something more automated and more powerful to support them. And this is exactly where Sibo sits. Sibo is sitting next to those teams. By reading the data from the entire process, from early raw material down to the 28-day strengths and everything in between, we help those people to take more automated, correct, and quick process-related decisions. It's possible to increase alternative fuel rates while running a more efficient production process, increasing capacity, optimizing quality, reducing costs, while keeping the carbon footprint low.
Those are a few very interesting and important tips and tools. Thank you, Liran. And now let's address altogether the elephant in the room. We know that cement manufacturers in the US face a very different set of circumstances to their counterparts in Europe when it comes to alternative fuels. Specifically because there are few, if any, government incentives. It simply doesn't make sense financially for American cement manufacturers to switch from coal. So, Ian, is there any way for American cement manufacturers to reduce emissions and stay competitive? For example, what can they learn from the European experience, particularly given the current US administration's green policy?
So we should look at this in the context that fuel costs are the single largest cost that cement producers incur, usually amounting to more than half of the variable costs. So when the Europeans started to look at alternative fuels, that was also a key motivator in addition to the reduction of the carbon intensity. So this is why coal is used so widely. And in addition to coal, petcoke is used as another low-cost but high-carbon fuel. And we only see limited uses of natural gas, for example, in generally in countries that have large gas production. So that might be an option in the US. It might be that at some stage natural gas is a possibility. You clearly have a substantial reduction in carbon footprint by using natural gas. And it may be that the US changes its regulation of waste so that it becomes more economic to do more complicated things with waste and to create more of a circular economy. But of course, using alternative fuels, as I mentioned before, is not the only way to reduce the carbon footprint of cement. Another way, and perhaps the most important way over the next 10 years, is going to be reducing the proportion of clinker that is used in the cement mix or blend. And in the US, the proportion is generally much higher than it is in Europe. So this is another area in which the US producers could look at the European experience and move towards a lower carbon cement. So this actually has a lot of the same sort of challenges in terms of process control, albeit at a different stage in the process. And so I think the kind of things that Liran's been talking about are also relevant there.
So all of these strategies that you've mentioned right now, whether it's using less coal or switching to alternative fuels or finding alternatives to clinker, they all require manufacturers to significantly optimize their processes, right? After all, on the surface, it seems that these methods should have the opposite effect. For example, using less energy should reduce kiln throughput, while using suboptimal raw materials should produce inferior clinker. So I refer this to Liran. Can you explain how artificial intelligence can overcome these challenges?
Yes. So some things are given. The weather is given, the raw material condition we have is given, the alternative fuels we have is given. Obviously, we can optimize each one of them. But at the end of the day, unfortunately, reality is reality. We will never get always perfect raw material. We will never get always perfect alternative fuels. And weather is going to continue to change. And in order to get the most out of it, we need to know how to tweak the process for today's conditions. And every day is a unique day. Using artificial intelligence, especially when you are not looking at one part of the process, especially when you look at the entire process, and you understand the relationship between alternative fuels, raw materials, weather, and the result, you can adjust the process to get the most out of what you already have. And with the right tools, you better understand your process. You better understand those relationships and better able to get the right decisions every day.
So from what I'm hearing, it seems that it's all about process efficiency. If they can optimize their processes, then cement manufacturers can both lower emissions and maintain or even improve key KPIs like energy efficiency, like kiln throughput, like clinker quality, and more. So no matter what fuels or raw materials they are using, artificial intelligence holds the key. So Edelio, this one's for you. Let's dive into this a little further. How would you summarize the goal of artificial intelligence, especially machine learning, in the cement industry specifically?
Yes, Noah. I will summarize it in 3 points. Efficiency and productivity is the first one. Reduce carbon emissions all along the value chain is the second one. And reduce cost is the third one. And let me explain these 3 points. First of all, machine learning is improving efficiency and productivity of cement and concrete production. That's obvious. And the next chapter is to detect what we call the new signals or the weak signals, learn from unused data or either consider useless with conventional tools, and link all these existing data sets from separated process parts. Just an example. In the cement industry, we're very much using what we call the Rietveld analysis, which is giving the clinker composition. This Rietveld analysis is based on the X-ray diffraction. Fine. But we're using the computed value given by the Rietveld analysis. We're not using the X-ray signal itself. And then we're here getting more and more accurate value if we're using this weak signal or this unclear signal instead of a computed value. By predicting the maintenance, you will save time, huge value by avoiding unexpected breakdowns. By predicting the quality, you will be saving clinker, which is the most expensive. And by adjusting the alternative fuel closer to the limit, you will save fossil fuel. So it's all about efficiency and cost. That's the first point. The second point is reduce carbon emissions all along the value chain. And here artificial intelligence, it's a way to reduce from prediction of the raw materials or the raw mix to the forecast demand by our concrete customer. So machine learning and artificial intelligence go beyond the single production of cement. The same applies for the concrete batching plant and the aggregate quarry. By getting all this data, you will be optimizing, and then you will be going closer to the limit of everything which is already allowed. So then you will be saving some carbon emissions all along the chain. For instance, we analyze the forecast demand, the demand by our customers, and we know better what and where it will be the demand if we are optimizing thanks to machine learning their demand. So it helps to optimize our production and to better comply with the timing delivery to the customer job site. It makes our customer happier. And this is just the beginning, where we know that there will be a clear trend in censoring concrete tracks to assess the key features of concrete while it's delivered to the customer job site. So by analyzing this data in cement, in concrete, the forecast demand, we will optimize the properties to be delivered and our customers will be happy. And machine learning goal is at the end to reduce the cost of everything, like over quality, unpredicted maintenance, breakdowns. Over quality, for instance, we do not have a real-time characterization of our products. We used to have safety margins in everything we do, just to make sure that the quality is not at risk for our customers. So with machine learning, the safety margin can be decreased, can be optimized, meaning less clinker and consequently a lower carbon footprint. Unpredicted maintenance, and that's my last point, and breakdowns are definitely a source of significant cost. So anticipating them is obviously a significant competitive advantage.
Okay, that's a very interesting point of view, Edelio. Thank you. And Liran, for our viewers who are considering adopting industrial AI, how should they get started? For example, what do they need to do to be data prepared?
So my first advice would be, before we even look or think about the data, would be to think and speak about the business. Every cement plant is different. Some has more demand than their capacity, and they would like to increase capacity. Others has less demand than their capacity, and they would focus on cost per ton. Some plants are in Europe, and they would be under specific regulations, and the other would be in other parts of the world where there is no regulation. So I would first focus on the business. I would first ask the plant manager or the team that we are working with, what are the goals that we would like to achieve? What is the prioritization? Once we understand that, we can also pinpoint what data is needed and tweak the algorithm. And I would like to explain. Sometimes demand is so important that you are willing that the cost per ton will be a bit high. And sometimes demand is so low that you would like to fight on every cent that you can do for the cost per ton. So it's not a fact that there is one formula for all plants. Even for the same plant, the formula is not constant. Maybe in the end of the year, you are like that. In the beginning of the year, you have a little bit of a different goal. So you also need to give weight to each one of your goals. And you need, based on that, to ask the algorithm to optimize to this specific point. So as a cement maker, I would first focus about the business. I would first understand exactly what are my goals and what is the thing that I would like to achieve. And only then I would work with my partner to identify the data that is needed. And once the data is in place, to analyze it and drive the savings.
Great. That's some really practical advice, Liran. Thank you for that. And this is the point where I say thank you very much to all of our panelists. Thank you, Edelio. Thank you, Ian. Thank you, Liran. And now we will move on to the Q&A section of this event. You can submit your questions using the platform, and we'll return in just a few moments to answer them. Thank you for joining us.